Hi, this is a demo video of a JackCompiler. So we have this latest release, and so this is a cross-platform compiler. So you have all the zip files that are needed for the particular operating systems for Linux, Mac OS, and Windows. So we are currently on Mac OS, and we'll just download this. And by the way, this as a note that this was all automated using a CI/CD pipeline that I built and used GitHub Actions for that. And yeah, we can just go ahead and run this. So in the this whole thing is packaged by the CI/CD pipeline. So and this is across all the platforms. So you will get this binary. That's the actual compiler that needs to be installed on the user's device. There's some example Jack code that the user can play with. This is also the OS files. This is also the OS files that needs to be compiled when the user needs functions like multiply, divide, or trying to allocate memory or strings or the arrays. So all the particular functions and the implementations are in these files, so those are needed. There's a readme.txt which explains the installation and a little bit about the compiler, and that these are the Python files that are needed to do the visualizer of the abstract syntax tree and the symbol table rendering. So the user can, with commands, can see if they want the abstract syntax tree or the symbol table. So, and by the way, this whole dependencies are installed using this install script. For Linux and Mac OS is the sh, but if it's a Windows, it's a batch file, or the process is similar. It take care all of it and installs the necessary dependencies of tools, the binary, and the OS files in the user's device. So everything is configured and ready to go. So let's just install it. So you can go to this folder, so cd desktop, JackCompiler, Mac OS. Okay, so we'll just run this install script. So yeah, this install script first detects what OS you're using and sees if you have Python or not. If you don't have a Python installed on the device, it will ask you to install Python and rerun the script again. If you have Python, it sees for the dependencies that there are two libraries that we needed, like textual and PyWebView. So they needs to be installed. If they are not, it will install it for you. And it's asking for your password because it wants access for the terminal, so that whenever you type jack and the file names that needs to be compiled. So to reserve the keyword jack in the terminal, we need some administration access. So it's so yeah, it's very similar and exactly, if not similar, exactly similar to how modern compilers like G++ for C++ work. So yeah, it's all installed. These are actually installed in the user, especially for Mac. They are installed in this root folder, where yeah, jack.toolchain. So it installs the binary, the OS files, and the tools, and the wrapper.sh, which take care of the jack command. So this basically reserves the jack command in the terminal. So yeah, we will have a look at it. So there's some example jack code that we can compile. So we'll just open the terminal and we can say jack dot, because this is all main files, or if you want, you can type it like this. We'll come to those flags, but if you just want to compile, you can just say like this and it will compile. Give me a second. I think you need some access. System settings. Yeah, you need to yeah, I think yeah, that should be fixed now. Yeah, Yeah, now you are fixed. So yeah, it will provide, it will do this, it will install, it will generate the VM files. It does all the tokenization, the formation of the parse tree, then semantic analysis, and then the actual uh, code generation to hack VM. In future, if you want, we can replace the VM code writer and code generation modules to whatever native architecture we want to do. So it's very modular in that sense. And yeah, you can now also see what the peak memory usage and the total time it take for build. And we can do the similar, instead of typing the whole thing, we can do this as well. Let's just delete these VM files so we can do it again. So we can do our normal, normally like in Git or in C++, we can just type dot. So it just means that all the files in the current directory needs to be compiled, and that works as well. And if we want, we can do the if you want to render the AST, uh, if you want to visualize your AST tree, the abstract syntax tree, we can do that with this flag as well. We can say jack dot dash dash viz dash AST. No, jack dot dash viz dash AST. Yes. Oh, wait a second. Jack dot dash dash viz dot dash AST. Yeah, that should work. Yeah, and it forms the parse tree, and you can compile. Yeah, the contents don't seem to appear because it's a really big file. When you start zooming on a particular section, they seem to, and they are color coded, so it's easier as well. And you can do it for multiple files. So that was for student, this is for the main file, and this is for the school file. You can do that as well. If you want, yeah, that's the whole, the visualization part was done through Python. And we can do the same thing as dash. If you want to visualize the global registry and the symbol table, you can do this, and it opens the global registry. So this is basically all your functions across all the classes that are being compiled, including your standard library, the OS files that we installed as well. So it includes them, and plus the symbol tables that needed. So you can see for the function, for the student class, in there's a static variable. Sorry, for the new function, there is argument for string, int, all the data types, and what kind of indexes are there in the virtual stack as well. You can do for the class scope as well. You can do, or you can check all of them, for just this for debugging. If the developer wants this kind of debugger, they can do it, and we can just quit it like that. And yeah, this whole the parsing tree and the symbol table and the global registry generation is done through exporting, the C++ exports these files as XML files and JSON files on the temporary folder of your operating system. So the Python, and then runs the Python script on them, which renders the AST and the and renders the symbol table and the global registry. And after they're done, they are automatically cleaned up and deleted, so it doesn't hog a user's memory. And yeah, that's it. Thank you for your time.